Hello, B-Day AP Stat students. I will be out today grading those AP FRQs, but I wanted to kind of make this video to kind of guide you along as you kind of get introduced to the chi-squared test. Now, I do know that there are a few people in the class that have seen chi-squared a little bit in biology class, so I would encourage you, if you want to kind of work with them, you can. It's actually good for them as well because it's going to help them for their AP biology. But we're actually going to like manually compute the chi-squared and then kind of use our table C as well, and also show you like the calculator commands. All right. So if we were to have class, I'd kind of give you some M&Ms and kind of check against whether the M&Ms are as advertised. And we all have favorite colors of M&Ms. And in theory, about 1 in 8 M&Ms are brown, 1 in 8 M&Ms are red, you're 12.5%. 1 in 8 are yellow. And then there's a little bit more orange and blue. Those are 25%. And this actually comes from like the manufacturer specifications for M&Ms. And we're going to kind of investigate, is this claim true? So you might be wondering, what is the symptom that we have a chi-squared problem? So when you have these multiple categorical variables, things like colors of M&Ms, then that's kind of a giveaway that we are looking at chi-squared distribution. What we would kind of do is kind of take our samples in class and kind of add them up. But in this hypothetical example, we get a little bit of deviance away from, the 12.5, 12.5, 12.5, 25% distribution. One thing that we definitely want you to kind of emphasize here is what the null and the alternative hypothesis is in a chi-squared type of test. So the null hypothesis is that the claim distribution of the color of M&Ms is true. So, the M&Ms are kind of as advertised in their distribution. And then the alternative is that the distribution is not true. So do the M&Ms kind of work as advertised in their distribution, or do they not work as advertised in their distribution? I'm going to kind of advise that you actually spend a little bit of time right now, pause this video, and spend a little bit of time kind of deriving the chi-squared calculation yourself. Actually, if you know how to like subtract two numbers and then square the number, you can actually get the chi-squared. It kind of teaches you how to get each piece in the chart. So I'm going to encourage you to pause the video and try out 3 to 5 on your own. If you're really stuck, then I'll explain it. All right, so this is a sample chi-squared calculation. So in the 440 M&M sample that we have, what we would expect is we would just do the expected percentages. So for instance, and I'm just going to kind of add a little bit here. We get 55 because it's 440 times 0.125. So 55 is 12.5% of 440. We get the 110 because 25% of 440 is equal to 110. So you always want to kind of be benchmarking against the expected. So you have the observed and then the expected. So in this hypothetical example, we got 10 more brown M&Ms than expected. And we are actually going to square that number. And that is why this is called the chi-squared distribution. And we like to square it because just like in the standard deviation, when we do like standard deviation and square, we want them to be positive. And then we divide by the expected as well, just so we can kind of see, like, if you're 10 off on, let's say, a brown, that is a lot more of kind of a deviance from expected than being like 10 off from, like, let's say, an orange. So what we kind of notice here is that when we look at each type and we do the observed minus the expected squared over the expected, we're going to kind of get one for each. And there are 6 different categories, and your degree of freedom is always going to be 1 less than the number of categories. So that's pretty important when you're kind of thinking about your table C that we're going to be using later on. And you get your chi-squared statistic just by doing the 15.48. I'd like you to actually play around a little bit. Go to the, like on number 7, play around with the applet on your own. It's kind of fun, actually. And you can kind of see, what the chi-squared distribution is going to look like. All right, so in class on A day, we are skipping kind of the example below this. I think on the AP exam, generally on the FRQs, you're going to be identifying but not computing the chi-squared, but just the idea of like identifying the chi-squared. But on a multiple choice, you might see some setups of like, how do you compute like a chi-squared statistic? And I think we saw that on a mock exam, actually. So the null hypothesis always is going to be that the distribution, the claimed distribution, is true of the categorical variable. And the alternative hypothesis is that the claimed distribution is not true. And the chi-squared, that sigma symbol is the formula on the formula sheet. But if you just kind of think about observed minus expected squared over expected, and then you can always just kind of use that chart approach if you're like manually computing it. But realistically, you'll kind of see like the setups on them, and you can actually do a lot of chi-squared tests, on your calculator as well. Once you get your chi-squared statistic, you get the number for like what you added up. That's your chi-squared. And if you're doing the chi-squared calculator command, I'm just going to kind of circle this here and tell you that this is your calculator command. And it's kind of found in the same place as your other, CDF functions. You put whatever your number is from your chi-squared, and it goes up to, 9,999, kind of a big number. And the p-value is just kind of a shaded area, like what percentage is it going to be? And you always just put the degree of freedom, which is just the number of categories minus 1. You can also use table C as well. And there is some table C's in the back of a classroom. So you are welcome to pick those up. Or you could use the calculator command. So that's kind of your choice. But they have a nice, kind of almost like your t-table, where you can just go to your degree of freedoms and kind of get that chi-squared value. I actually kind of like you to flip to the next whole page and kind of get introduced to the 4 C's. And there's a lot in common with 4C analysis and the other significance tests that we've done, but there are also a few small differences as well. I like you to kind of try out as much as you can on your own. Maybe do it in pencil, and then you can fire this video back up. All right. So this is basically the M&M example in the 4C format. So there's a few types of chi-squared tests. The most common types you're going to see are the chi-squared goodness of fit and the chi-squared test for independence. And we'll do independence next class. There's always going to be a significance level. But one thing that is not happening are the parameters and the statistics. And we have a, kind of categorical variables here. So your null hypothesis is always going to be that the claim distribution is true. And then the alternative hypothesis is that the claim distribution is not true. There are a few things that are in common with other significance tests. Make sure you're including and checking that your sample is a random sample. So we kind of have a single random sample of M&Ms. And the 10% condition is something that you also want to check as well. So in theory, that 440 M&Ms is way less than 10% of all M&Ms. And then the expected counts is this is kind of the analogy of like large counts. But we just want the expected counts for all the categorical variables. So this means the browns, the reds, the yellows, and the greens. We are actually looking to be greater than 5. And instead of normal distribution, we're going to say that the distribution is a chi-squared distribution. In terms of the computations, you can do the formula approach, and you'll kind of see this type of formula setup on like multiple choice questions. Observed minus expected squared over the expected. Or you could do kind of that chart that we did on your bell work. And the numbers, you can actually do them in your calculator as well, but it's going to be about 15.48. And then you can use either the calculator command or the table of value, table C. And this is going to get you a very low p-value. And the conclusion is that there is a very, very low p-value, getting that chi-squared of 15.48 or greater purely by chance. So if you kind of include that verbiage, that's good. And then you can kind of include your usual rejecting of the null hypothesis and say that we do not, or that we have convincing evidence. We do have convincing evidence that the claim distribution is not true. Sometimes you might be asked for a little follow-up analysis. So they might ask you, where is the largest component of the chi-squared? So where is there going to be most of the error? And to kind of be thinking about that, you're going to kind of look at your chi-squared, and you're going to see what your largest number is for your chi-squared. So the thing that's kind of the most off is the red, because it's 15 off compared to a 55 for the expected counts, which is a lot more than, like being 17 off from like 110 for your expected counts. So that's why that's going to be the largest component. So they might ask you a follow-up question for that sometimes. But this is just the general 4C method with the terms and conditions, chi-squared goodness of fit today. We'll talk about a few other chi-squared tests next class. And then the usual interpretation of p-value, decision, and inclusion. That is continues to be true. And actually, a lot of people were able to kind of redeem themselves on that chi-squared FRQ question we did on the mock exam at the end, just because they kind of have that conclusion statement with the p-value. All right. I want you to kind of try out before you do your IP a 4C type of example. And this is kind of looking at a traffic light, and it has 80% red of the time. The yellow is 5% of the time, and then the green is 15% of the time. That's what it's set up to be. And a guy is kind of worried that the traffic light is not performing as expected. So we're kind of asking ourselves, is there convincing statistical evidence? So if you had a 200 sample size, 80% of 200, so 0.8 times 200 would be 160. So that's what we would expect. So if you want to kind of see it animated a little bit here, I'm going to do 173 minus 160. And I'm going to square that and put it over my expected. And then 5% of the time, this is 0.05 times 200. So we would expect that 10 of those times we would see a yellow light, and then we would automatically assume, if we want to kind of get to that 200, that there would be 30 green lights going on. So what I kind of want you to do is I want you to kind of fill in the rest of this chi-squared computation and do your 4 C's to see how this chi-squared works. And then your IP is listed on Google Classroom and on the course website as well. Feel free to let me know, email me if you got any questions, and we will do a little bit more chi-squared tomorrow when I see you again.